Hello and welcome back to Longevity by Design. I'm your host, Dr. Gil Blander. I recently was in California to present in a nutrition conference at UC Davis. And I had the opportunity to interview Dr. Eric Verdin, the CEO of the Buck Institute. The Buck Institute was the first center dedicated to aging research, and many discoveries with the aging field have come out of this research center. I would like to mention that we interviewed Eric in episode 17 a couple of years ago. Me, Ashely, and Dr. Verdin sat down in his office to discuss the latest update in longevity research. I asked Eric his opinion about is aging a disease, and is there a maximum lifespan that humans will never suppress. Eric also shared updates on the future of anti-aging drugs, discussing senolytics and other. To close the episode, Eric gave life advice for what 5 things we can do on a regular basis to improve our health span. Eric is very smart, insightful, and realistic. The three of us had a great conversation, and I learned a lot. If you enjoyed the Longevity by Design podcast, support us by rating and reviewing it. Thank you.
Welcome to Longevity by Design, a podcast designed to give individuals access to the leading scientific information in the field of longevity. The ability to add years to your life and life to your years needs no opinion. Join us as we ask science to take the wheel. In each episode, Dr. Gil Blander joins a co-host and an industry expert in the field of longevity, shining a light and getting the answers to the key question: how can we live a longer, healthier life?
Hello, I'm Ashely Reaver, and I'm joined by Dr. Gil Blander. Welcome to Longevity by Design, How to Live a Longer, Healthier Life. We're produced by Insight Tracker, your science-based guide to optimizing your body from the inside out. Today, we are joined by Dr. Eric Verdin at the Buck Institute.
Good to meet you. Thank you for being here.
Thanks for hosting us.
Thank you so much, and it's an amazing institute. That's my first time and Ashley's first time, and it's really impressive. So I'm recommending everyone to come and visit. And I know that you have some tours that people can do, correct?
Yes, and let this meeting stand as an invitation to any of you who want to come and visit us.
Yeah, and you are the CEO of the Buck Institute. And the Buck Institute is the first and only institute that focuses only on aging research in the world. So very exciting for us to be here because we are representing Longevity by Design. And would love to hear a bit about the institute. Can you tell us a bit about that and what is the reason that this institute started?
Yeah, so we started in 1999. And we were founded by a gift from Beryl Buck, who was a local philanthropist here in the Bay Area who wanted to do something specific for Marin County. And one of our founding board members, Jack Rowe, came up with the idea of creating a new research institute that would be focused on aging research. And one of the reasons for doing this at that time was there were, back in the late 80s and mid 90s, a whole series of papers by Tom Johnson, by Lenny Garante, Cynthia Kenyon, Gary Rifkin, that all, showed that aging could be studied using the modern tools of molecular genetics and molecular biology. And I think it really changed our whole perception of what aging was, and it could actually be studied using the modern tools of biology. And so the vision of the Institute as it was founded was to basically provide a home for people to do this. And this is what we've been doing for the last 24 years now.
Interesting. And Eric, any groundbreaking research or result that came from the Institute in the last 24 years?
Yeah, I would love to think so.
Can you give us one couple of examples?
Yes, I think, first, just to give you an idea of who we are, we have about 300 employees. We were the first one, and we are, I believe, are the largest one. I have a running argument with Nir Barzilai about this. But the idea of having a full center that's focused only on aging obviously was very novel at the time, but it's been followed by a large number of places. There are other institutes also in Europe and in the country. We like to think that we were the first ones, and we still are the biggest. But so what areas, we have focus, we have 24 faculty members, about 300 employees, and we sort of focus on both on the basic mechanism of aging and the most simplest model, like think about fruit flies, C. elegans, or mice. But we also have people who are really focused on studying disease that are associated with aging, like Alzheimer's disease and macular degeneration and so on. And I think if you think about where have we contributed, would be first in really digging into each of the hallmarks of aging. There's a particular focus at the Institute on cellular senescence, in large part due to the work of Julie Campisi, who is one of the pioneers in the field, but also Julie Anderson, who has shown senescence occurring in the brain during neurodegeneration and so on. So senescence is actually really occupying much of our efforts, including the founding of Unity, which was the first company to generate senolytics. Mm-hmm. The whole concept of geroscience, which is this idea that aging as a process is the major risk factor for all of the disease associated with aging, and that by targeting aging pathways that we have been identifying, you should be able to suppress the development of these diseases as a group versus individually, as traditional medicine is doing. So I would say senescence. But we've also had groups working on mitochondrial biology, on autophagy, on nutrient sensing. So if you think about the hallmarks of aging that your audience is probably familiar with, I think we try to have a balanced faculty that really addresses each of these as recognizing the fact that aging is a pleiotropic processes, that there's not such a thing as a unique mechanism that accounts for aging, and that by studying all of them and finding the synergies between these abnormalities during aging, hopefully we'll get to a more comprehensive answer to solving it.
There was a great discussion on glucose metabolism in the cafeteria that I was listening in on.
Cool.
Just a lunch conversation.
Yeah, we have many groups. Obviously, metabolism is really central to all of aging. We have many groups, including my own, that do study metabolism.
Yeah, and I bumped into Judy Campisi in 1995. She published a paper in PNAS, I'm sure that you know that, about senescent-associated beta-gal.
Yes.
And I remember reading it in a big excitement and trying to reproduce it and use it in my model experiment in the Weizmann Institute at that time. So Judy is definitely one of the leaders in the aging research, and it's amazing that she is here. And we hope to interview her maybe in the future. So Eric, at ARDD, and ARDD is Aging Research Drug Discovery Conference, one of the biggest conference of aging research in the world. You show that you got tested with a lot of DNA clocks, and you got a very interesting result. Can you discuss it a bit? I think that will be interesting for our audience to hear it from you.
Yeah, so all of us recognize that the development of biomarkers of aging is really going to be key for the field. Both, no one is planning to do a 30-year clinical trial to decide whether an intervention is really working or not. So identifying surrogate markers that really would predict, how you're going to respond over a shorter time period is really key. So, and obviously the epigenetic clocks are a key step in this development. So we've been working in my lab on really trying to understand what do these clocks measure. And this is maybe just anecdotal, but in some way for me it was important to do because it showed me that even though these tools are the best we have today, there still are early tools and in my opinion not ready for sort of a prime time. As I had my DNA analyzed by the Clock Foundation by Steve Horvath to map all the methylation sites. And once you do this, you can, it's called an epic array, you can then actually take any of the existing clock and apply it to the same sample. And we did this, and my age varied from 66, which is my chronological age, to 42. And there were no two clocks that actually showed the same age. Some was at 55, but the good news is that they were all younger, so I'd love to think that I'm
in a good shape.
That I'm in reasonably good shape, but I think the discrepancy just showed me that these clocks are all measuring something different. And I did, just another clock, which is called glycan age, and this one showed me to be 25, which was, interesting because we really don't know what it means. Yeah. So I think the message for me was that even though these clocks are, revered in the field and exciting as potential tools in the future, there's still so much we do not understand that we should take them with a grain of salt, especially for their intrinsic value, so that your age measured using one of these clocks is really a question, of variables that we don't understand. What might be more important is to see how each of these clocks is varying as a function of time or as a function of interventions. And so that's what I'm planning to do every 6 months. I'm going to repeat the same experiment and try to see how do these clocks vary? Do they vary, in the same way, in different ways? And so we'll see. I think it's obviously not science, it's more anecdotal, but I think it's an important sort of reality check for us in the field. And I'm not the only one who has done this. I think other people have made the same observations.
Yeah, I heard it from Nir Barzilai, by the way.
He did the same thing?
Yeah, then the same the same observation, that it's very confusing. But I think that it's more like the trend, as you said. It's more, as you said, most of all of them made you younger, so most likely you are younger. But it's very hard to say if you are 66 or 45. You are somewhere in between, and none of them knows that yet. That's how I see it.
But the secret also of all of these clocks, if you look at them, they all have a bias to predict that you're younger at older age. If you look at the curves, they're not linear, they sort of plateau. So in some way, they are built to actually satisfy the older people to think that they actually are younger than what they really are.
Yeah, we have our own clock called Inner Age, and actually we have like a nice distribution, normal distribution, that more or less half are older and half are younger. And actually we see it when someone receives older age. I see it as a good point, because then he is pissed and he work harder, and then he's later on improve his inner age or clock. So I agree with you that it should be a good reflection of, and it should be normal distributed and not skewed to make you happy, because the goal here is not to make you happy, but make you live longer.
I agree. So, another point is, I think, we are entering a new phase of biology where the clocks, which is a multi-omics type of data, should only be one part of the equation. We've just recruited Lee Hood and are building a big collaboration with this effort called Phenome Health. And what they're proposing to do, and we're going to be doing together, is using not only epigenetics, but transcriptomics, proteomics, metabolomics, all of them together to try to derive, the strongest predictor of aging. And obviously, there's a lot of, we already know there's a lot of hidden data in metabolomics, and I suspect the same will be true for all other omics. So the vision that we have is really to go beyond the epigenetic clock to build a multi-omic clock that will be much more precise and might actually include a whole series of granularity in terms of other disease risk for specific disease and so on. So I think, and I'm convinced that there's a lot of biological information that's hidden in plasma or in blood, and we just have to learn how to read it.
Yeah, and for our audience, we interviewed Lee Woods a few months ago. So there is an episode that we discussed his recent book together with Nathan Price. So if you're interested, I'm encouraging you to go and look at that episode. Ashely, the ball is.
I have a weird question about funding.
Yes.
Aging as a research field obviously isn't necessarily new, but I'm sure public opinion of studying aging seems somewhat new, thinking that there's somehow some way you can interfere with that process for, getting grants, as you said, a lot of your funding comes from, or even fundraising. Have you seen a shift in people that are interested in aging research?
Yeah, I think right now, it's not my analysis. Everyone who's working in the field has seen it. There's just been, I've worked in the field for 20 years. I think you even longer. There was so much excitement at the beginning from what was being done in the animal models. Everyone thought, of course, the whole world is going to follow us. Well, turns out that it took a lot longer than what people were expecting. And I would say from what I've seen, we're entering this upward side of the hockey stick. So, a lot of big innovations and discoveries take a long time to percolate through the public consciousness. But I would say right now there's so much interest and so much excitement that people are finally getting and understanding what we're trying to do, which is not necessarily to make people live to 100, but more to make them live healthy as long as possible. And I think there's an enormous amount of interest in the public. In young scientists also, we see the same thing. This is, I've never worked in a field, and I've worked in other fields before, where when you interview people, there's so much excitement about what this field offers. I'm convinced it remains one of the sort of last big frontiers in terms of understanding biology and what defines us.
It's interesting. When we talked to David Sinclair, one of our very first episodes, he was saying he was trying to petition Congress to get aging labeled as a disease. I don't know, what are your thoughts on that?
David and I have had sort of an open discussion about this, so he won't be surprised to hear me. I do not like the idea that aging is a disease. The same way I do not think it's necessary. We have a whole series of other abnormalities that occur in living organisms that are not necessarily disease, but are recognized as risk factor for disease. Yeah. The problem of labeling aging a disease is that automatically you label, the whole population. You start aging at age 30, we're all sick. It just doesn't make any sense. It creates. It might sound sort of cool and attractive as an idea, but it also recreates a backlash. And I've seen this backlash mostly with the medical profession. Not to say that the medical profession knows everything and does everything right, but there are many ways to pursue our goal in a way that's a little less confrontational and more integrative. And I think I've argued that labeling aging as a disease only contributes to this rejection of what we're trying to do. And in some way, we can do a lot of, actually the TAME trial was approved by the FDA without labeling as a disease. And so why couldn't we do everything else?
Can you elaborate on that? I'm not sure that our audience know what is the TAME trial.
So the TAME trial was a proposal by Neil Barzilai and his colleague to test a treatment of aging with metformin. Actually, I don't remember what the exact TAME. Maybe someone can look this up, exactly what it means. Targeting aging with metformin. And so the idea is that metformin is a calorie restriction mimetic. It sort of fools the body into thinking that it might be lacking nutrient, and there puts it in a fasting-like mode. And there's some preliminary evidence, which is now a little bit controversial, that diabetics on metformin seems to be living longer than non-diabetics. And so the question is, what happens when you give metformin to non-diabetics? Do you actually, can you prevent the occurrence of a whole series of chronic disease of aging? And this is what the TAME trial that Nir and other colleagues, Steve Allstadt, went to the FDA and got it approved as a clinical trial.
Yeah, and that's a very exciting. That's the first clinical trial, as much as I know, that looking at the endpoint of some of the endpoint is longevity, yes, but also other diseases that are related to aging. So I agree with you. It's a very exciting development that we are just seeing. So talking about that and getting into, drug or intervention, so do you see in the near future or in the future a drug that can significantly extend the lifespan? And if yes, what do you think will be the magnitude?
Yes, and I do see these drugs coming. I mean, we have them in animal models. Mm-hmm. That's the first example, and there's nothing unique about human biology that would lead one to think that it's not doable in humans. Although I've argued that humans already live very long as a function of their body weight. There's a linear correlation between body size and life expectancy, and you can draw a line between all mammals. The problem is that humans are already way above that line, not like other animals. And the problem is also that mice lie under this line, which means there's probably much easier to increase lifespan in a mouse than it will be in humans. But that being said, I think there's enough data with rapamycin, for example, in a whole variety of organisms, including some non-human primates, that suggests that it might actually be feasible. Now, what will be the first drug that enhance aging in humans? I think there are, rapamycin is definitely one.
Yeah.
That's one we are actually currently discussing or conducting a clinical trial to test it directly in humans. Metformin is another potential one. Senolytics is another potential one. So I think it's hard for me to imagine that in the next 10 years we will not have the first drug that targets a true aging process and lead first to a treatment or prevention of disease and eventually to a longer lifespan. That would be, that being said, I think I also think that we already have an anti-aging medicine today, and which is a physical activity. Mm-hmm. And I'll just give you one statistics, which is that 30 minutes of walking every day will decrease your year-over-year risk of heart disease, stroke, cancer, Parkinson's by 40%.
Wow.
And my prediction has been that, and we know, exercisers live on average 7 to 10 years longer than non-exercisers. My prediction is that to find a medicine that does this is going to take longer than 10 years.
Yeah.
And so I've argued, and this doesn't really make me popular, that I think in the aging field we should focus more on understanding these lifestyle factors which can profoundly influence our life expectancy and our health span. And so, that would be, nutrition, physical activity, sleep, stress mitigation, and social connection. So there's a lot of work I think that needs to be done there. And, inside Tracker, as I'm sure you have a lot of people that you're following where these lifestyle interventions have been shown before to be really important in terms of our health span. So for me, the idea of popping a pill, hoping to increase your lifespan without having optimized everything else doesn't really make much sense. And I think, I always tell people the best way to be ready for when these magic drugs are going to come and be proven to actually increase your lifespan will be to optimize everything else you can today, because this is something that we know works for sure. It's been tested and it's been demonstrated. So that's my vision, sort of a two-step way in which we focus on understanding and optimizing these lifestyle factors. And second, in the future, or in not so distant future, we give these drugs initially to people who are at the highest risk of accelerated aging. One thing a point that I always make is everyone, is focused on finding these drugs, but we know there's not such a thing ever as a drug without side effects.
Yeah.
And so when we embrace, drugs that are targeting the aging pathway, we should be aware that many of these drugs will probably decrease your fertility, because we know there's a balance between fertility and lifespan. So these are all things that, when I get asked by a 25-year-old whether he or she should go on metformin, I feel very strongly that this should not be part of the equation of healthy aging, at least not at 25, maybe at 60 or at 55 it could make sense, but not early, because there will be secondary side effects.
Yeah, no, I agree with you, and I think that it's a prevention versus treatment, and as you said, there is so much to do right now because our healthcare system is built for treatment and not prevention, and that's exactly what we are doing at the Insert Tracker. We're trying to expose to the world prevention and exercise and sleep and lifestyle and supplementation. And by the way, thank you so much for being an Insert Tracker user, and we have a lot of our users watching you today or listening to you today, so that's very valuable for us. You mentioned in your answer senolytics, and I'm not sure that our audience know a lot about that, so can you elaborate about what are senolytics?
Yeah. So first, let me define the concept of senescence. Senescence is a cellular program that cells use to stop dividing once they are sensing some stressors. So for example, if cells are dividing too many times, their telomeres might get eroded, and there's a signal that will force them to stop dividing. That's a process called replicative senescence. But senescence can also happen if a mutation happens in a gene that we call an oncogene, a cancer-causing gene. The cell might start dividing in a way that's abnormal. Again, there will be a trigger that will force it to stop dividing and rest. The process of senescence is also used during wound healing. So it's not only a stress signal, it can also be something that's used by the body. The problem is typically these senescent cells will stop dividing, and they start churning out inflammatory molecule, probably to signal to the immune system that they're in trouble. And the task of the immune system then is to come in and kill them. And this works throughout life, starting probably at 20. Or even earlier. The problem is that we find that as individual or animal models age, the clearance of the senescent cells becomes limiting, so that they slowly accumulate. As they accumulate, they keep churning these inflammatory molecules, and they contribute to the chronic inflammation associated with aging. So there's been some evidence, actually from Judy Campisi here at the Buck, that and Jan van Dersen, who was at Mayo Clinic at the time, was that the idea, if you genetically engineered a mouse to allow you to eliminate the senescent cells in an older animal, this animal will actually live longer and be protected against the chronic disease of aging. So out of this came the idea, instead of a genetic trick the way we do in mice, maybe we could generate specific molecules that are targeting the senescent cells uniquely and killing them. And so that's how Unity was founded. And they were able to identify a whole series of small molecules, drug-like molecules, that actually selectively kill senescent cells. And some of these molecules are in clinical trials, and they recently reported on some positive effect in some eye disease, specific eye disease, glaucoma, and diabetes-associated retinopathy.
Okay. Do we see these cells more in certain tissues, like fast or tissues that we have to replace more often? Do we find them?
I would not be able. I don't know the exact data. I mean, these cells are typically rare, but they are. They exert a dominant effect. For example, there was a recent interesting paper by Laura Niederhofer showing that they were able, using a genetic trick in the mice, to induce senescent cells only in the immune system. And what they found is that these immune cells that became senescent were able to induce secondary senescence in multiple organs. In my lab right now, we have a big program studying senescent cells in the human immune system and trying to understand what are these cells doing, how could they be pathogenic and so on.
And as you mentioned before, there are, depends on who you ask, 10 or 12 or 9 hallmark of aging. And do you think that each of them works separately or they are working together? So basically, like for example, solving the senescence problem, that will be a solution for all, or we'll need to solve also the insulin pathway, another?
Yeah. So I think, the hallmark of aging in some way were misunderstood. I think they are not individual occurrences. I mean, they are a series of, right now I think we're about at 10, according to the latest paper, 10 individual problems that are associated with aging. And they've been really helpful in terms of organizing the field, people working on autophagy or working on nutrient sensing. So it's been a really interesting way to look at how aging pathways might be connected or not connected. I think we've entered a different phase now where people are finding all kinds of relationship between these hallmarks of aging. For example, I'll give you an example. Senescent cells actually induce, these inflammatory molecules. So that group of molecules is called the SASP. You can simply generate the SASP by taking the medium of a culture that has senescent cells. So we did this and added it onto other cells, and we found it induced a molecule called CD38. And CD38 is an enzyme that chews up NAD. So NAD is involved in nutrient sensing. So it's a way by which two hallmarks of aging communicate. But there are dozens of these examples. I think everyone recognizes aging is pleiotropic. It involves multiple abnormalities, and I think the next 5 years we'll probably see many, many more examples of these interconnection come. I mean, why is this important? Because one sort of simplistic view of aging initially was that, well, if we identify all of these problems, we're going to find a drug for all of them, and we're going to be able to pool these drugs and then solve all the problems together. The problem is that if you interfere with senescence, you might be interfering with nutrient sensing. So there's a lot of connection that I think we're going to have to better understand to come to generate drug cocktails, hopefully, that are actually synergistic and not antagonistic.
Yeah, and they might be personalized for each person. I think that the cancer field is a good example. In a way, we had a race to cure cancer, 50 or maybe more years ago. And we realized more and more that it's specific. Each of us have a specific mutation, and each mutation causes a different kind of cancer, and the intervention is different. So in my opinion, it will be similar in aging. I might be aging more because reactive oxygen species. You might aging because of senescent. You might aging for you because inflammation or insulin. So I think that it's, in my opinion, it should be personalized at the end. It won't be a one solution fit all.
I think it's a key factor, not only for the aging field, but for all of medicine. And as you interviewed Lee Hood, you've already talked about P4 medicine.
Yeah.
He came up with the idea that, one of the P's in P4 is personalized. And so the idea is that we are, there's a big discrepancy right now between what's happening in the lab and what's happening when you deal with the human population. When we work in the lab, typically most labs work with one strain of mice. Yeah. They're called Black 6. Yeah. And all of these Black 6 mice across the world are pretty much the same mouse, one mouse. So it's as if, and we base a lot of our effort in, developing drugs and then bringing them to the market based on this one mouse. It's as if we were to study one human and then say, okay, let's give the same drug to everybody. So obviously, there's a lot of things that fail between the one mouse and the billions of humans. And the way we think to move forward, which has been proposed by Lee Hood, is to really to generate highly personalized interventions. And we don't know, the short answer is that we don't know how to do this, but this should not stop us from trying and really getting to a true personalized medicine.
Yeah, and if we are staying with the analogy for cancer, I feel like we are in the early days, like we are maybe 50 years behind the cancer research in a way. So we don't have even the first drug for aging. In cancer, we have hundreds of drugs already. So we are really early. And I like your point about the best policy is a lifestyle, because the next drug won't come tomorrow. It might be 10 years, maybe 50 years. So
Yes.
in the meantime, let's be as good as possible to be alive or be around to use those drugs. So
I agree.
I think importantly too, the people that are going to get the most benefit from those drugs aren't those that are already incredibly sick.
Yeah.
They're those that are already doing so well.
Exactly. And the prediction is also, if you think about from a regulatory point of view, the FDA, which, sometimes are being decried or complained about, are still there to ensure that the drugs that are in circulation are actually not hurting us.
Mm-hmm. Yeah.
And the standards might be too high sometimes, but I still think, the worst thing that could happen to our field is to put a drug on the market and to end up, killing young people.
Yeah.
And this is what happened with gene therapy, where it was initially touted as the biggest revolution, but eventually they had a few really unfortunately deaths, which put the field back by 20, 25 years. And I think as a field, aging research should be really cognizant of this history and try to be really careful in terms of what we advocate for people.
Yeah. One more comment about a side effect, maybe. So you said, and you are right, that any drug there is a side effect for. And a few days ago, there was a publication about GLP-1 drugs, and it was considered in the last few years as a silver bullet, but now we are starting to see more and more side effects of those drugs. So
Yes.
I think that even the silver bullet for weight loss, and I think that there are some evidence that it might be even for longevity. Those drugs have some side effect for some people. So again, personalization and side effect, and we need to be careful with drugs.
Yeah. And one of them for the GLP-1 agonists like Ozempic and others is, for example, loss of muscle mass.
Yeah.
They've shown that it's great to lose weight, but if you lose your muscle mass.
Yeah.
So I think it's like any field, now that we know this is a potential risk factor, you probably would recommend to people who go on these drugs to have a strength, program and so on. And I think there's no question, if we're going to go to a drug, there will be side effects, and we'll have to mitigate them and understand them before we start recommending them.
Yeah, absolutely.
In the past 100 years, we've improved lifespan pretty significantly. Are there any things on the horizon, perhaps, that you can see that aren't necessarily pharmaceutical interventions that you could see? Or can you explain why we've been able to live so much longer in the past 100 years? Are there anything like that kind of out in the future, maybe?
Yeah, and sometimes I'm a little bit critical about modern medicine in the way that it is, if you think about it, it is not really embracing the whole science of aging and so on. But I think we also should, or is too focused on disease, is not enough on health. But on the other hand, I think we all have to recognize that where we got today is due to medicine. And so in some way that should generate a significant amount of respect and really study from our young field of the process that led to these successes. So if you think about what led us to where we are, some of it was medicine, some of it was simple public policy, but driven by science and driven by understanding and medicine. I mean, some of the biggest ones are sanitation. Obviously, having potable drinking water is absolutely huge. The fight against infectious diseases, in the early 1900s, people were mostly dying from infectious diseases, and we've conquered many of those. First with, antibiotics, aseptic surgical procedures. These were the early big discoveries: sanitation, nutrition. The fact that fortified flour, all of the understanding of vitamin deficiencies and so on. What else? I'm trying to think about what else. Antivirals, are coming online. When I went to medical school, we were told that, antibacterial antibiotics were really the key discoveries of the 20th century, but this would never happen for viruses. And now we have antivirals against HIV, against hepatitis C, and the list goes on and on. So that was the first phase of, progression. The second phase has been really the ability of medicine to treat people with chronic disease of aging, heart attacks, or cancer. And these are the two big killers. So if you want to increase life expectancy, I think these are the two that you have to address. And medicine is doing a much better job both at preventing and actually at curing cancer and heart disease. So I think now that we're all living longer, we are actually faced with a whole series of new challenges. And I want to add one more thing, because quite often, as a sort of, I call myself more like a realist in the field, and I don't really believe in that dramatic life extension is going to happen anytime soon, or even later. People call me, pessimistic, or not being able to understand, how AI is going to change everything. But one thing that is, and it's true, AI is accelerating our work. Biology is becoming much more powerful. So there's clearly an acceleration of our knowledge of biology. But I also think people fail to recognize the problems that we're trying to solve are harder and harder. Having a bacterial infection and giving an antibiotic is really an easy fix. I haven't seen anything in our work, or in the work of anybody else for that matter, that would allow you to say that we're going to have an antibiotic-like molecule that's going to, dramatically increase lifespan.
Yeah. So talking about that, genetics is also playing a role in a lot of different diseases and processes. What is, in your knowledge or in your opinion, the role of genetics? And if you can go in percentage, more or less, what percentage influence of our longevity? What percentage of the influence of longevity is due to genetics?
The old number was 20 to 30% genetic versus 70 to 80% lifestyle factors, the environment. I think that's what's generally accepted. There's one paper that I think that was published by the Calico group that suggests that the number when actually been skewed in the wrong way, sort of to give genetics a bigger role than it actually has. And what they were able to show is that using what I think is the largest data set to try to decide, and this is actually the ancestry type of database, they claimed that genetic only accounted to about 7% of lifestyle and life expectancy, and 93% was actually lifestyle factor. Yeah. So I grabbed onto this because I think the paper is really solid, but also for a second reason, which I think is incredibly empowering. Rather than having a fatalistic vision of your lifespan, it just means it's on you. Yeah. And whatever you do, whatever we do is going to determine your lifespan. Near Barzilai, you used to say that, if you want to live long, you have to choose your parents well. Yeah. And I always loved this, but in some way, this is probably not true. Near is correct in one respect, is that this genetic versus lifestyle balance seems to be true for most of us, except for the current centenarians, who seem to be, many of them don't have a very healthy lifestyle, and not unhealthy, but not particularly healthy. Many of them are smoking or not eating well, or not exercising, but they still got to be 100. And there's also some other papers showing that there's an index factor that you can calculate based on the number of long-lived ancestors you have. And if you have quite a few of those, you tend to live longer. So I think, mostly lifestyle for us, for the few lucky who have long-lived ancestors, then maybe you're going to lead another lifestyle. Yeah,
and I like Nir like to tell jokes, I'm sure. Yes. So I remember one of his joke about he came to a lady that she's 110 or something like that, and she's smoking. and he's telling her, "Are you crazy? Why are you smoking?" And he asks her, "Your physician didn't tell you that smoking is not good for your health?" So she's telling him, "Yeah, the two of them that told me that, they're already dead." So that's taking a joke aside. I think that what Eric said here is very important for the audience to understand. 93% of your longevity is basically controlled by your behavior. So nobody can come and say, "Hey, it's in my gene," other than those gifted, long-lived people, but they are gifted. But all the rest of us, if you eat well, sleep well, exercise well, and try not to do other stuff that are not well, like smoking, you have a good chance to live longer. And it's almost all of it in your control. So don't come and say it's in my gene. No, in your gene is only 7%.
Something I feel like we don't necessarily address so much on the podcast, maybe more in social science, is how much your zip code also influences your life expectancy. We're in beautiful Marin County, which I think has the longest life expectancy in the world, in the United States. There's obviously factors that allow individuals in Marin County to have access to certain things that perhaps people in, I think Alabama has one of the counties in Alabama has the shortest life expectancy. What is it about Marin that makes people live so long?
Yeah, it's a fascinating, area of investigation, and one again that doesn't get enough attention. Again, sometimes our field is perceived by the outside world as medicine by the rich for the rich, which I think is not good. It's true, Marin is one of the longest lived county in the country. It is, I believe, the longest lived in California. But what's really interesting is that even within Marin, you see pockets of where lifespan, for example, there's a town called Ross where life expectancy is 88. Mm-hmm. There's some other areas of Marin where life expectancy is 72. So the 16-year difference. Wow. Again, it's largely driven by socioeconomic factors. And I think one area that I think our field is not focused on enough is understanding these huge discrepancies. Now, there's a whole field, and the merger with aging field has not happened. This is the area of investigation called the social determinants of health. Mm-hmm. That was pioneered in England and eventually recognized throughout the world that there are incredible discrepancies between different pockets. And one classic picture is the one that shows the life expectancy on each of on the London metro, showing big differences in really different neighborhoods. But you see the same thing in Glasgow, another study in Cincinnati. Sometimes 20-year difference. In the US, we see right now a huge discrepancy between the two coasts, and Midwest were generally long-lived, and the Southeast, which is really has much shorter life expectancy. A lot of it is driven by socioeconomic factor, but it's not only poverty. It's because even within areas that are very long-lived, the less rich people are still living longer. Mm-hmm. I think it's and we should study this a lot more. And I think we should focus, of course, both on increasing maximum longevity and health span for everyone, but also focus on those who are already at the highest risk. Because in some way, these are the people who are the most in need of really understanding. Now, typically, the response from scientists like us when I talk about this is, well, this is nothing to do with science. This is a problem for politicians to solve. No. This is a reflection of inequality in society. But I don't agree.
I agree.
I don't agree because I think we should provide politicians the understanding that we don't have, frankly, of what are the major, for example, levers that we could actually push on to change these equations. And I'm sure not every, people will say, well, it's education, it's maybe meals in school, maybe it's physical activity during school. There are so many things interventions that are probably going to impact more people than the drugs that we're talking about right now that could really raise the level for everybody to live healthy. Yeah. So I think as scientists, we need to be more engaged in this debate. And I would love, we've talked about trying to do a study here within Marin to try to target some of the communities that show the shortest lifespan, because again, they're breathing the same beautiful air, same blue sky, same weather. So what is it? Why do we see 16 to 20 year differences in life expectancy for people living together? I'm convinced that these are the types of variables that are the source of society instability. These inequalities are, and I'm not a socialist or a communist. If someone wants to label me this way, I'm just aware of the fact that as a field, I think we should be part of this debate and hopefully study what are the major variables and provide them with the politicians so that they cannot hide behind the fact that, well, this is society and there's nothing we can do about it.
Yeah, and I've seen similar study in Chicago.
Yes.
And there it's amazing. Like you can be in a distance of 1 or 2 miles from each other, like in the suburb or in the middle of the town, and the difference can be as high as 20 years.
Yes.
And part of the explanation, if I recall correctly, is the food desert. So basically you don't have access to fresh fruit and vegetable, and you have a lot of McDonald's and not whole food, and you work too hard, so you don't have time to exercise. As you said, 30 minutes of walk a day is like an apple a day. So there are a lot of things like that, simple things that we as more gifted have more time and more we have time to watch such a podcast and learn from that. And they need, no, seriously, they need to work all the day, and they're working double shift, and they are basically in survival mode. And we are more in leisure mode. We can take. So I think that there is, but I agree with you that it's not clear, and I think that that's something that it's a good opportunity for us, the academic or the elite, to also support the whole community and not only take care of the billionaire, millionaire, and the gifted people.
I agree.
I think that I've seen an interview of you a few months ago, and you discuss basically how long the population of people would like to live. And I want to ask you, what is, if you could live to any age, what will be the age that you want to live to?
Oh, I would live to 1,000 if I could be in good health, and surrounded by my family, my friends, and active in society. So to me, it's not, there's no limit in my mind in terms of how long I could live. I love living, and one of the beauties of aging is that you are happier and happier until you hit, a point where disability and loss of function actually take a toll. But so I find that to me is really the key is the functionality. What kind of life are you leading? And the question is, how long will we live? That's quite often the biggest question. And I would say I call myself a realist right now. We've been gaining 2 years of life expectancy every decade for the last 150 years. As I mentioned, science is accelerating, but the problems are getting harder and harder to solve. So in some way, if we were able to keep gaining 2 years every decade, in 100 years, we will have gained another 20 years.
Yeah.
And that means, that would be already remarkable. We would be at 100.
Yeah.
So that, to me, is more likely to be the trajectory that we will see. Now, is there a maximum lifespan to humans? Right now, all the evidence point to the fact that it's around 115, except for a few glaring exceptions.
Yeah.
Now, that doesn't mean that in the future we will not be able to do something really different, in terms of, bringing some tools that we haven't even imagined. That's why I don't like to make predictions, and I do not believe anybody who makes predictions, because I'm old enough to have lived in a world that had no cell phone and no calculators. Actually, I still remember I was in high school when the first pocket calculator came in. And I know that makes me sound like a dinosaur, but it was still amazing that you could just, type in and do a multiplication. And I still remember also the Cray supercomputer, which It was absolutely amazing to watch, and people told us the number of operations did by second. And now we're all walking with a Cray supercomputer, actually something that's more powerful than a Cray supercomputer in our pocket. So there's nothing, on the other hand, I think I tell people that, making analogies with the tech world, which is highly scalable as a technology, is very dangerous because biology is much more complicated. And it involves human lives. If you make a telephone that doesn't work, it crashes, that's the end of it. If you give a medicine to someone and you kill them 10 years earlier than what they were supposed to live, I think it gets very complicated. That being said, I'm an optimistic. Also, I think that we've entered an incredibly exciting phase where aging is considered a tractable biological problem. And I think, who knows what will happen? For me, it would already be amazing if, humanity would continue its march to living longer and better. On the other hand, the counter side to this is right now we are in the last 5 years, in the last 3 years, we've seen a drop in human life expectancy in the US. And, obesity is a menacing a public health emergency that's, I don't think, is being addressed adequately. The opioid epidemic and COVID. And so, and increasing resistance from the population to accepting science as sort of the ultimate arbiter of what. So I think we've got a lot of work to do. And the U.S., lagging most other countries in the Western world in terms of its life expectancy, again, because of what these discrepancies that we've talked about. So I think I'm an optimistic, but I'm also a realist. And I think I tell people at the Institute always, let's under-promise and over-deliver, rather than all of the hype that I think surrounds us regarding the aging space, or nonsense like talking about immortality or curing death and all of this. So that really, frankly, I just gave a talk at a meeting in Switzerland, which was a diatribe for about 20 minutes against the idea that we should never talk about immortality as a field. It just doesn't help anyone. I mentioned in an interview recently, if you want immortality, I think you should go to church, but don't come to us.
But even the sun died, so immortality doesn't make sense.
Exactly. Yes. Yeah. But even 1,000-year lifespan, all of this, there's nothing today that will allow us to say we're going to be able to do this.
And you mentioned at the beginning of your response an interesting point that I think that's very important for us to double click on. You said that I would live to 1,000, but I want to live in a good health, meaning that you are talking about the difference between lifespan and healthspan.
Yes.
And maybe if you can define what is lifespan and what is healthspan.
Yeah. So. Well, healthspan is the healthy years of life in which you are living productively, in which you're not chronically ill. And lifespan is how many years you live. One of the things that has happened with our lifespan increasing is that our healthspan is not growing at the same rate as our lifespan. So the two curves are diverging, which means that as we age, we spend a longer and longer fraction of our life afflicted by these chronic disease of aging. And right now, for most of us, it's about 15%. So your typical adult who would live to 80 starts being sick at 65 and then spends 15 years of different quality of life, either with a heart attack or cancer, which really degrade the quality of your life. Now, and so right now, when people ask me, what is your goal? I tell them, first is to maximize health span. Because at the end of the day, no one wants to live long and sick. So if we could already bring everybody to live close to 80 in good health and have a shorter demise, I think that would already be an incredible achievement, both in terms of quality of life, but also savings for all of our social security systems, Medicare, and so on. Now, what makes me think that we can actually do this is the centenarians. We talked about them earlier.
Yeah.
They not only, by definition, they live to 100. That's how you become a centenarian. But they spend a shorter fraction of their lives afflicted by disease. So typically, your typical centenarian would be about 5% of their lifespan. Mm-hmm. That means, they live to 95 in good health, and then the last 5 years they will become sick and die. So the real delta between a centenarian and a regular person is about 30 years of healthy life. And based on the numbers that we see today, for example, here in Marin County, the longest lived community lives to 88 on average. And assuming that all of this is driven by lifestyle, I can guarantee you that living here, not everybody is optimized. Not everybody exercises, not everybody watches what they're eating. So it's reasonable to expect that most people living an optimized lifestyle could live to 90 to 95 in good health.
Yeah.
So, and I think this is really, for me, this would already be a 95-year-old health span would already be an incredible achievement. And I'm convinced it's reachable today based on lifestyle optimization. So to me, that's enough right now. If I could finish my career here saying we did it and the whole country lives to 95 in good health, that would be, transformative, frankly. There's no other way to look at it.
And in your opinion, what are the interventions to push the health span as close to the lifespan? What are the most important interventions to do that?
So we mentioned it's nutrition, and nutrition, we can expand on what nutrition means. It's not just what you eat, but it's also when you not eat. It's the whole idea of fasting and so on. Physical activity is a big one. It's actually one of the strongest one. And when people say physical activity, typically they equate this with sports. Well, it's not sports. It can be simply walking, but also gardening. It's just being mobile, moving, not sitting in a chair like we are actually. I have to move. And there's some evidence that people, who move constantly during the day actually live longer, just being more active, engaging your muscle. But key questions that are not answered: what kind of a physical exercise? Is it weightlifting? Is it cardio? Is it balance? Is it stretching? I think it's a combination for all of those. But again, science here could actually help providing the tools to measure what is the effect of these different forms of exercise on longevity. Sleep is a big one for me, one that no one talks about. The country is chronically sleep deprived because of lights, artificial lights, but also now screens.
And Netflix.
And Netflix, exactly. And sleep in some way for me is really important for a number of reasons, because I know that if I have a bad night of sleep, all of my willpower and my determination to lead a healthy lifestyle goes out the window. I'll crave carbohydrate, I'll start eating, I'll go to McDonald's, I'll do all of the things that I'm not supposed to do because I'm tired and I'm a bit cranky and so on. So optimizing your sleep is really important, especially for brain health. There's a lot of evidence emerging that is critical. Stress mitigation is also key, not so much the external stress, but how you perceive it and, how you mitigate it, how you diminish it. And the last but not least is human connections, which is, by the way, in several epidemiological studies, is the strongest predictor of your lifespan. And why is that? No one knows, because we can't study, human connection in mice. So I think, again, a lot more work should be done in this. What is it about having a strong social network that makes people live longer? I think it goes back to having a purpose, having a sense of belonging, just being surrounded by people. But these are all areas that are so hard to measure for us in the lab. Most of the field basically ignores them. Now, one last point that I wanted to add. So I think about all of these 5 buckets as bank accounts that if you want to live long, you should be filling them individually. And you don't have to put money in every account every day, but every time you put a little money in one of the accounts, it's going to come back to help you. Because there are studies showing that these effects, the effect of nutrition, the effect of physical activity, of sleep, and stress mitigation, human connection, are all additive. So if you look at people who don't exercise but who do all of the other, they live longer, but you add exercise on top, they live even further. So think about it. Think about the 5 buckets as bank accounts, and the higher each of the bank accounts are, the better you'll do in as a whole.
I think that that's an important point to say. You don't have to fill all of them all the time because you probably can't. And if you're trying to, your stress is probably going to go up. Or you're going to be stressed because you can't put all of those in there. Each day doing the best you can is what you can do.
Yeah.
Yeah. And I think that it's a great segue to finish our podcast. Like, we didn't even had to ask you the question, what is your recommendation? Because you provide them. So if Eric, you just can repeat it and say, what are the 5? And then we can finish in this note that basically every one of us can live better, longer, and increase his health span by just doing the 5 that Eric will mention right now.
I'm happy to come back. I think each of them could be, either with me or other people, could be a full discussion. Like nutrition, physical activity, sleep, stress mitigation, human connection.
Yeah. So that's, I think that's a very good summary of what can we do to live better or longer. So Eric, it was a pleasure visiting you, and thank you so much for hosting us in your office. And
my pleasure. Good to see you both.
And it's a beautiful institute and a beautiful location. And as Eric said, all of you are invited to come and visit and see the best institute that studied aging in the world.
Definitely the prettiest, I have to say.
Thank you.
But it's also the best. So
let's not be shy.
And it was a great pleasure. Thank you so much. And talk with everyone again soon.